Alright, this is now question 4, last one from this first practice exams for your response section. This question deals with this highway problem. If we look at the beginning of the problem, it says that there is a traffic modeling application. Segment of highway is represented by a two-dimensional array of integers, which each row represents one lane. Each column represents a multi-lane cross-section at a given position. So again, rows are lanes, columns just represent like different positions on the road. So a value of 1 signifies that a car is there. A value of 0 signifies that it's empty. There isn't a car at that spot. All cars are moving in the same direction. Cars can also make lateral moves, so like switching lanes, which would be like switching rows, so they can go up or down if they're switching lanes, but they're all moving in the same direction. In the picture there, the example, the highway has 4 lanes, 4 rows, and all the traffic is moving to the right. It says to simulate continuous traffic, in a stretch of highway in the model, a car that goes out of bounds on the right. So once a car reaches the end and leaves the array to the right, it reappears in the back of the same lane. So if it gets the last column and it moves forward, it just jumps all the way back to the first column, the initial column, and then continues to move to the right. The model is implemented with the help of the class highway. The partial definition of the class is shown on the next page, and it says you'll write 2 methods of this class. So we have the highway class. I kind of wrote this out just so I could refer to these things as we get started on this. It's important if they give you a class, break it down, look and see what the big sections of the code are, things that are going to be useful to us, and go ahead and be thinking about those as we go. So the highway is represented by a two-dimensional array called highway HWY. We have a constructor that builds the highway with the number of lanes and the number of columns, which is this length variable here. We know that lanes is row and length is column because when you build a two-dimensional array, it is row majority order, which means the row comes first, then the column. Alright. We have this method addCar, which simply goes to a lane or a row called lane, a column called X, and it sets that row and column, that position in the two-dimensional array to be 1. So that was a really simple way of adding a car if we wanted. It's not listed here, but if there was a remove car method, it would simply go to a position and set the value equal to 0. Basically make that spot empty. So the first thing we're going to do is actually write this can-switch-lane method in part A. There's another method called move all sideways that we may use. I do want to mention not every method listed has to be used, so this may be something we do use, it may be something we don't use. Alright, but the implementation for this is not shown. It simply says that any cars in the highway attempt to switch lanes, something about the probability. Says with the probability 0.1 up and the same probability down. All cars that can make such a lateral move do so. The probability of a car not attempting to change lanes is 0.8. Okay, so that would be like some type of random way of shifting the cars around, using probably using like a math.random instance to come up with a probability, some type of decimal number, to determine if the car should switch lanes or not. Just kind of getting an idea of what it should do. Again, implementation is not shown. It doesn't say it's implemented in Part B either, or Part A, or there's not a Part C in this problem, so it doesn't look like we're going to have to write that, but it may be useful. We'll see. And then finally, you have Part B, the method move forward, which moves all the cars in all the lanes forward by 1 position. And if there's a car in the last position, it moves back to the first position, so the first column in the same lane, same row. Alright, so we're going to get started with this first Boolean method, can switch lane. So since it is a Boolean method, what that means is we need to return true or false. And if you think about the name of the method, can switch lane, that means if the car can switch lanes, it's probably going to be a true. If it can't switch lanes, it'll probably be false. It's at least what we're assuming here. So if we look at page 153, it gives us the instructions to write the method. It says a car at a certain row lane and column X can move in direction -1. So if direction is -1, that means up. If there is a lane -1, so if there's a lane above it, if it exists, and if there are no cars at position X, so remember X is the column, so if there are no cars in that column in any lanes above the current lane, so all the way down to the first lane. So if we look at the example, and I kind of drew this up over here on the side for us, just in case we would need it. Any car can move up if the direction is -1. That means we're looking to move up. And it says, I'm just looking ahead, if direction is +1, then that means we are looking to move down. And the method takes in 3 parameters, one of which is the direction. So it's going to tell us which direction we're trying to check. Can we move down or can we move up? So it can move up only if there is a lane above it, and if there are no cars in that same column above it. For instance, if we look at this picture here, this car right here could not move up because there's no lane to move up into. Alright, so that would return false. As I go down here, obviously this one would be the same thing. It's in the top lane. This car right here, second lane, or I guess this would be, if I was to label these, lane 0, 1, 2, 3. So lane 1 and position or column 3, this car could move up because there is a split spot above it and there are no cars in the same column above it. Okay, so this one would be good. If I keep looking, this one, there is a lane above, but there is a car there, so it can't move up. So that would return false as well. So far we've seen 3 falses and 1 true. Let's just keep kind of getting an idea of what this does. These are, if you notice, the ones that can move up are bold in the example on your paper. If you look at lane 2 and at position 1, column 1, this one is not bold. Why? Because there is an open spot above it, but there is another car in the same column. So even if there is a spot above it that's empty, if there is any car in that same column, it's not allowed to move up, probably for safety reasons. You don't want this car trying to move up and this one trying to move down at the same time, and you get a collision here. So the only way you can move up is if there is no one in the same column above you. And the same thing is going to go if we're trying to move down. The only ones that could move down here would be this car right here. There's an open spot and there is space below it, and nothing else except this one over here. So you see those 2 bold number 1s and the second example for the ones that could move down with a direction of +1. So let's get started writing this method. So method header, public boolean. So we are returning a boolean, true or false. Can switch lane. Takes in 3 parameters. The lane of the car we're checking, the direction it wants to move, and the position x, which is its position on the highway. Remember, the position is simply like the column. Okay, and we can see all those parameters defined in the comment right above the method. And then again, it tells us return true if it can switch lanes in that given direction, otherwise return false. So when we're doing this, the first thing we probably want to check is, alright, based on the direction, is there even a lane above it if we're trying to move up, or is there even a lane below it if we're trying to move down? So if there aren't, then we automatically know it can't switch lanes. We want to return false. So to me, that's pretty easy concept, pretty easy thing to check, and that will at least give us some points, even if some of these other parts are a little difficult. So I want to check and see if we're trying to move up. How would I signify that? If I'm trying to move up, the direction must be -1. So if the direction we're trying to check equals -1, okay, so if we're trying to move up, when are we guaranteed we won't be able to move up? If we are in this top row, right, in the top lane. So if we're trying to move up, and the lane we're in is the top one, which is lane 0, so if lane equals 0, then what do we want to do? We want to return false. We can't switch lanes. Alright, so that's a given. Same thing's true if we're trying to move down. And I'm going to put equals on both of these. I'm trying to move down, and the lane is the last lane. Okay, so from this last lane out, that depends on how many lanes we have. So how can we get access to the number of rows? Okay, there wasn't a property listed. If you look back on the previous page, there wasn't a property for how many lanes we have. We know that lanes was used to refer to the highways, how many rows we have, but we don't have access to like that number of rows exactly. But we always can get it if we have access to the actual 2-dimensional array. Remember how this works. If you use the name of the 2-dimensional array .length, that tells you how many rows you have. If you use the name of the array with a bracket 0.length, that tells you how many columns you have. So if we want the last row, okay, let's look at this example. This one has 4 rows, so the last one is for minus 1. So if the lane equals the number of rows minus 1, then, and we're trying to move down, we know we can't do that either. So there's another one we can return false on. Right? So now we've taken care of those two scenarios. As soon as, and remember how this works, as soon as we hit a return, if that return is met, so if we already check these, code won't even go any further. It returns false and leaves the method. Okay, so we've accomplished this purpose. We pretty much have guaranteed ourselves, I would think, at least a couple points with these two conditions here. So now we just need to check and see, all right, are there any cars above us or below us in the same column? If we're trying to move up, are there any cars above me in that same column? If we're trying to move down, are there any cars below me in that same column? And we would also return false there. We can't switch lanes. Anything else, if none of those conditions are met, then we must have open lanes either above us or below us, so we should be able to switch, in which case we'll return true. So let's do just a couple more if statements here. Let's say if, and let's think about this. Let me pause for a second. Let me think about how we would do this. We need to check all the lanes above us if we're trying to move up, right? So let's just go back to a simple case. Let's say if we're trying to move up, that means the direction is -1. So we want to go to our current spot. We want to check. I'm going to just use this this one as an example. So I'm trying to see if I can move up. Then I want to go to my current spot and start checking here and look at all the lanes above me in that same column. So I'm going to set, try and keep up with which lane I'm referring to. I don't want to use the word lane, so let's just call it row, since that's really what it is. And let's set the row equal to the one right above us, because that's the first one we want to check. So our row is called lane. We want to check the one above us, which is lane -1. Okay. So then we want to go through all the rows until we get to the first row, right, or row 0, so to speak. And so here's what I'll do. I'm actually going to tell you what. I'm going to make a for loop out of this. We're going to say start at that row, keep checking all the rows until we get to the last one. So as long as the row is greater or equal to 0, and then row ++. Actually, I take that back. I'm not going to do row ++, because that would check the next row below. And we'll go from here down this way. So we're actually going to do row -. And we're going to say if we come across a car anywhere in that row, we want to return false. Right? So I'm going to say if, remember how we access each individual element of a two-dimensional array. We go put the name of the two-dimensional array, which in this case is HWY. Remember, this method is in the same class as the highway. It's in the highway class, so we have access to this array. So if we go to the current row we're looking at, and the column is the same column that the car is in, which is listed as X. So if we come across a 1, that means there's a car there. We want to leave our method. It's not going to work. We're going to return false. Okay? So that's going to be our for loop. And this should have been indented, but I kind of added that in last second. It's okay. If your indentation is off a little bit, but you have braces to signify what you mean, then you're okay. You don't have to worry about going back and erasing that. All right. So we've checked and seen if there are any cars above. Now I just need to do the same thing if it's below. So if the direction is +1, let me shift this down just a little bit. Then I'm going to say for each car below that, so let's go to the, instead of starting at the lane below us, let's start at the lane right above. So lane +1. And again, I don't have to worry about checking, well, what if we're in row 0? Because that should have already been checked up here, right? Let me think about this for just a second. So here's what I'm wondering. What if they, actually no, I take that back. So we don't have to, I was worried, what if this condition up here wasn't met, but we were actually in row 0 trying to ask this question anyway, and it couldn't happen, because if we were in the first row 0 checking to see if there were any lanes above us, that would have already happened here, and we would already have said no to that. Okay, so we don't have to worry about maybe going out of bounds, because that's what these two conditions up here check. So we actually already took care of that. Sorry for that delay. So now, if we're trying to look below, if we're trying to shift lanes down, again, we've already checked to make sure that we're not in the last row, so this isn't going to take us out of bounds. It's going to check at least one lane. So then we want to keep going as long as we are have not gone out of bounds. We know we'll have gone out of bounds if we reach the last row. If we go beyond the last row, remember the last row is always the number of rows minus 1. So to get the number of rows, we do highway, the name of the two-dimensional array dot length. So as long as it's less than that, so length minus 1 is the last row, then we won't, when we check and see if it's less than length, then we're still okay. And then we want to move down each time, so row plus plus. Okay, and we want to check sort of the same thing here. If go to the current row, add the column X, same one as as our car is in. If there's a car at any point in our pathway, we want to return false. Okay, so we have now checked to see, are there even lanes above us? That was the first two return false statements we saw. Then we checked, did we ever come across any cars, either if we're trying to move up, were there cars above us in the same column? If we were trying to move down, were there cars below us in the same column? If there were, then we return false in those conditions. If we checked all those things and there are no cars in the way, and we do have lanes available, then all we want to do is add in one more line down at the very bottom of our code and return true, because there must be open lanes and there must not be any cars in the same column as us. So in that case, we want to return true that we can switch lanes. Okay, so a little complicated, little lengthy bit of code. But again, this is just a two-part question, so we could expect these to be just slightly longer than we saw in question 3, for example. All right. So that's question 4A. If you have questions, again, you can leave a comment, or you can ask me questions, send me an email, or talk to me in class. All right. So go on and try part 4B. I believe this one will be much smaller, maybe a little more tricky to think about, but I think the length of the code will be a little bit smaller when we get to it.